Hello, Miss Thinker here. Your daily source for mind-blowing facts, forgotten history, and powerful motivation. Today I will talk about how do black holes form. Have you ever looked up at the night sky and wondered about its deepest, darkest secrets? What if I told you there are monsters out there, cosmic behemoths so powerful that not even light can escape their grasp? Today we are diving headfirst into one of the most mind-bending topics in the universe, the science of black holes. So, what exactly is a black hole? Imagine squishing an object with a massive amount of matter into an incredibly tiny space. The gravitational pull becomes so intense that it creates a one-way street in the fabric of space-time. Anything that crosses its boundary, the event horizon, is trapped forever. It's not a hole in the traditional sense, but a region of space-time with gravity so strong, it's inescapable. To understand how these cosmic monsters are born, we need to look at the life and death of stars. Most stars, like our sun, will end their lives relatively quietly. But for stars that are truly massive, at least 8 to 10 times the mass of our sun, their death is anything but quiet. These giant stars burn through their nuclear fuel at an incredible rate. For millions of years, the outward pressure from nuclear fusion in their core perfectly balances the inward crush of gravity. It's a cosmic tug of war. But eventually, the fuel runs out. The outward pressure disappears and gravity wins catastrophically. The star's core collapses in on itself in a fraction of a second. This implosion triggers a spectacular explosion called a supernova, which can outshine an entire galaxy for a brief period. While the outer layers of the star are blasted into space, the core keeps collapsing. If the remaining core is massive enough, about 3 times the mass of our sun, no known force in the universe can stop the collapse. It compresses into an infinitely dense point called a singularity. A stellar mass black hole is born. These are the common black holes, ranging from a few to a few dozen times the mass of our sun, scattered throughout galaxies like our own Milky Way. But there's another, much larger class of black holes, the supermassive black holes. These are the true galactic monsters, with masses millions or even billions of times that of our sun. And here's the wild part, we believe one of these giants, named Sagittarius A*, lurks right at the center of our own Milky Way galaxy. How did these behemoths form? The truth is, we're still piecing together the puzzle. One leading theory suggests they started as smaller, stellar mass black holes in the early universe. Over billions of years, they grew by devouring gas, dust, and even entire stars that strayed too close. Another idea is that they formed from the direct collapse of massive clouds of gas in the primordial universe, skipping the star phase entirely. It's also possible that multiple smaller black holes merged together over cosmic time to form these giants. It's an active area of research, and every new observation brings us closer to an answer. For a long time, black holes were purely theoretical, a consequence of Einstein's theory of general relativity. How do you even see something that's invisible by definition? Well, we don't see the black hole itself. Instead, we observe its effects on the space and matter around it. One way is by watching stars. Astronomers can track the orbits of stars that are very close to a galactic center. By measuring their speed and path, they can calculate the mass of the unseen object they're orbiting. At the center of our Milky Way, we see stars whipping around a dark, empty point at incredible speeds. The only thing that could have enough gravity to cause that is a supermassive black hole 4 million times the mass of our sun. Another method is to look for accretion disks. As matter gas, dust, and stellar debris gets pulled toward a black hole, it doesn't just fall straight in. It spirals inward, forming a hot, glowing disk of material called an accretion disk. The friction and intense gravitational forces heat this material to millions of degrees, causing it to emit powerful X-rays and other forms of radiation that our telescopes can detect. These accretion disks are some of the brightest objects in the universe, and their presence is a telltale sign of a feeding black hole. But the most groundbreaking evidence came in 2019. The Event Horizon Telescope, a global network of radio telescopes working together, achieved the impossible. They captured the first ever direct image of a black hole's shadow. This wasn't a picture of the black hole itself, but of the dark silhouette it casts against the glowing, superheated gas of its accretion disk. The image from the galaxy M87 showed a ring of light, bent and distorted by the black hole's immense gravity, surrounding a dark central region, the event horizon. It was a stunning confirmation of Einstein's theories and gave us our first real look at the edge of spacetime. And then there are gravitational waves. When massive objects like black holes or neutron stars collide and merge, they send ripples through the fabric of space-time itself. These are gravitational waves. In 2015, the LIGO and Virgo observatories detected these waves for the first time from the merger of two black holes over 1 billion light-years away. It was a sound from the silent universe, a new way to observe the cosmos as most violent events and a powerful confirmation that black holes are real and active. So are black holes just cosmic vacuum cleaners, mindlessly swallowing everything? Not exactly. While they are incredibly powerful, their influence is more nuanced. Supermassive black holes at the centers of galaxies play a crucial role in galactic evolution. The immense energy and radiation blasting out from their accretion disks can heat up and blow away the gas in a galaxy. This process, known as feedback, can regulate star formation. It can either trigger bursts of new star birth by compressing gas clouds or halt it entirely by clearing out the raw material. In a way, these galactic monsters are also galactic gardeners, shaping the structure and life cycle of their host galaxies over billions of years. They are an integral part of the cosmic ecosystem. Now, let's address the big question. What happens if you fall into a black hole? Let's imagine you're on a journey toward a stellar mass black hole. As you get closer, you'd experience extreme tidal forces. The gravitational pull on your feet would be so much stronger than the pull on your head that you would be stretched out like spaghetti. This process has a terrifyingly cool name, spaghettification. It would be a rather unpleasant end to your journey. For a supermassive black hole, the experience is a bit different. Because they are so large, the tidal forces at the event horizon are much weaker. You could actually cross the event horizon without being immediately torn apart. An outside observer would see your image slow down, fade, and freeze at the edge, never actually crossing. But from your perspective, you would pass through the event horizon into the region of no return. What lies beyond the event horizon? According to general relativity, all paths lead to the singularity, the point of infinite density at the center. Here, our current laws of physics break down completely. We need a new theory, a quantum theory of gravity, to understand what truly happens at the heart of a black hole. Is it a gateway to another universe? A tear in the fabric of reality? Or something else entirely? We simply don't know. But the story doesn't end with eternal darkness. Stephen Hawking famously proposed that black holes are completely black. Due to quantum effects near the event horizon, they can slowly leak radiation, now known as Hawking radiation. Over unimaginably long timescales, this causes the black hole to lose mass and eventually evaporate completely in a final flash of light. This idea introduces the famous black hole information paradox. If a black hole evaporates, what happens to the information about everything that fell into it? Physics says information can never be destroyed. It's a profound puzzle that physicists are still grappling with today. From the explosive death of giant stars to the silent, gravitational heartbeats of merging behemoths, black holes represent the ultimate extreme of physics. They challenge our understanding of space, time, gravity, and the very nature of information. They are not just objects of destruction, but key players in the grand cosmic story, shaping galaxies and driving the evolution of the universe. The next time you gaze at the stars, remember the invisible giants lurking in the darkness. They are a reminder that the universe is far stranger, more mysterious, and more wonderful than we can possibly imagine. Thank you so much for joining me on this journey into the abyss. If you enjoyed this cosmic exploration, don't forget to like, subscribe, and hit that notification bell for more adventures into the unknown. Let me know in the comments what cosmic mystery you'd like us to unravel next. Until then, keep looking up.